All right, good morning, you guys. It's Wednesday, May 6th, and I have good and bad news for you, okay? The good news is this. The good news is starting next week, we are going to be done with chapter 4, okay? So for our last 2 weeks of the school year, we're going to actually be working our way through chapter 5, which is an important chapter, at least for us to get a little bit of exposure to, okay? The bad news is we do have one more round of notes on on chapter 4. We're on section 4.5 right now, and it's going to continue on with the same theme that you guys have been seeing for the last couple, about the last week or so that we've been in chapter 4. Is sticking with that same word, murky. It's weird, it's goofy, it's kind of confusing, and really, I know you guys probably are a little bit frustrated because you feel like when you're going through the homework, you're almost more like seeing the answer in the back of the book and just trying to work your way from the start of the problem that you see and have wrote down to the end that the back of the book says you're supposed to get to, and you're more or less trying to fill in the steps. So unfortunately, today is definitely going to be more of that, okay? The thing I need you guys to really understand right now is this, all right? If you take a college level calculus class, which I'm anticipating you guys will, my goal for this chapter is that when you see it next year or your sophomore year, or whenever it is that you take your college calc course, you see it and your gut reaction is, oh God, I remember this stuff and I didn't like it. As opposed to staring blankly at the professor, wondering what in the world they're talking about and hoping you're not the only person in the room that has no idea what's going on, okay? This is all about exposure. It's so that you've seen it before, so that you're not going to be a lot further along than people who haven't seen it, but at least you won't be panicking because you've never seen it before. So just bear with me as we go through this. I know you're going to have questions. I know that tomorrow's clarification video is going to be probably one of the longer ones we've had in a while because there's probably quite a bit of stuff we're going to have to work through, but just bear with me, okay? What we're going to do today is we're going to do differentiation involving logarithm functions, okay, which is something new. We haven't differentiated much that's not written in a certain way, okay? So what I need to preface this with is showing you and reminding you of what we did a while back, which was called implicit differentiation. Implicit differentiation is something that we do when we have a function that's not explicitly solved for y, okay? So like this, 2x plus y equals 3y squared minus 4x squared. We can just do implicit differentiation here. The way you do implicit differentiation is anything that's just written in terms of x, you differentiate the usual way. So what's the derivative of 2x? It's 2. What's the derivative of negative 4x squared? It's negative 8x. But the way that you differentiate something for y, or in terms of y, is you find its derivative. So what's the derivative of 1y? That would just be 1. But then you attach the fact that we're not trying to differentiate in terms of y, we're trying to differentiate in terms of x. So the way you do implicit differentiation for anything in terms of y is you find the derivative of y and you multiply it by dy dx. So you multiply it by the derivative of itself. Okay, so you do the same thing here. What's the derivative of 3y squared? That would be 6y. But again, anything that's not written in terms of x, you multiply it by dy dx, which is the derivative. Okay, and then what it is it's just manipulating the equation. You move anything that's got dy dx over here, and you move anything that doesn't over here. So we literally subtract 2 to move it to this side, and we subtract 6y dy dx to move it to this side, minus 6y dy dx. It'll all come back to you eventually here. So what we have right now is we've got and actually what we have is we've got both terms that have a dy dx. So we factor them out, dy dx. When you factor that out of this one, you're left with positive 1. When you factor it out of that one, you're left with minus 6y. Over here, you're literally left with negative 8x minus 2. You divide this to get your derivative. dy dx equals negative 8x minus 2 over 1 minus 6y. So your derivative itself, your derivative of your function has x's and y's in it. I just wanted to remind you guys of that before we get into this murkier stuff, okay? So, moving from that to this, okay? Derivatives of logarithmic functions, and I'll post pictures of this. I'll try to remember to take a picture of this and post it. If I forget, just email me. But we're going to find the derivative of logarithmic functions. So here's a logarithmic function, y equals ln of x, or y equals the natural log of x. What we've been talking about the last couple days is logarithmic functions are just exponential functions written in different form. So what is the base? I don't really want to write it on my notes here in marker, so here. ln means log base e, so it's log e of x. How do we rewrite this in exponential form? It's e raised to the y equals x. E raised to the y equals x. So all we're doing here is we're kind of writing some things down that we know. Y equals natural log of x is basically the same thing as e to the y equals x. Now, if you take this function right here, e to the y equals x, and you differentiate it, remember this, we're going to use implicit differentiation, but what's the derivative of e to the y? It's its own derivative. That's why it's kind of a unique number, is that e is its own derivative. So if you think about what we did on that last problem when we were differentiating y and 3y squared, we did the derivative times dy dx. So that's exactly what we have here. E to the y is its own derivative times dy dx equals the derivative of x is just 1. Okay, so all we did right here from here to here is we did implicit differentiation. Now I'm going to solve for the derivative. I'm going to divide over to the other side and get 1 over ey. So here's the derivative. The derivative is 1 over e to the y power. But now if we do basic substitution, what is e to the y power? It is x. So if I replace e to the y in the bottom of the fraction with x, I get 1 over x. Now, if we go from here to here, y equals the natural log of x, the derivative of that is 1 over x. So, what I want you to understand right now, and I know I can see your eyebrows raised already, when you differentiate a natural log, the derivative of the log is just the fraction 1 over whatever you're finding the natural log of. So, put simply, whenever you differentiate one of these functions, wherever you see ln of something, all you do to put its derivative is write the fraction 1 over whatever that is. Okay? So, the thing we have to really, I guess, recognize here, though, is this. That only works when you're just having the natural log of a single variable x. If you have the natural log of anything other than x, you have to multiply it by the derivative of whatever that is. But what is the derivative of x? The derivative of x is 1. It's basically the chain rule, okay? So it's maybe going to kind of make a little bit more sense. I don't know if it's going to make sense, but you might be able to follow the steps when we get down to these examples. Look at the first function. It's f of x equals natural log of 2x. So like I said up there, I know I'm talking kind of fast, but whenever you have to differentiate a natural log, the derivative of a natural log is the fraction 1 over whatever the natural log is of. So to differentiate natural log of 2x, it's just 1 over 2x. But you have to multiply that by whatever the derivative of that expression is. So what's the derivative of 2x? It's 2. 1 over 2x times 2, the 2's cancel, you're left with 1 over x. You're going to see some repetition, at least in these first two examples, because the first two examples are just natural log functions. So how do you differentiate the natural log of 2x squared plus 4? Again, whenever you differentiate a natural log, you just put the expression under 1 in a fraction. So it's 1 over 2x squared plus 4, but then you have to use the chain rule and multiply it by the derivative of the inside. So what's the derivative of 2x squared plus 4? It's just 4x. So if we go to clean this up, it's 4x over 2x squared plus 4. Technically, at this point, I could factor out a 2 from the bottom. The bottom would become x squared plus 2, and I could divide 4x by that 2 to get 2x. So that's what it would clean up to. The part where things are going to get really murky today is when we have to apply product rule, quotient rule, and all these other things, all these other properties from the last 2 days' assignments. So if you look, number 3, it's the product rule. It's x times natural log of x. This is the product of two separate functions, an x function and a natural log function. So we have to do the product rule. The product rule is the derivative of the first function, 1, times the second function. So it's 1 natural log of x plus the original first function, x, times the derivative of the second. Well, what's the natural log of x's derivative? 1 over x. If you go to clean this up, 1 times natural log of x is natural log of x. Let me just erase my markings on my notes. And over here, the x's cancel. It's just natural log of x plus 1. So this is the product rule, and still remembering that the derivative of natural log of x is 1 over x. Okay, compare that to number 4. Just make sure you guys can still see this. Hopefully I haven't led my paper off the screen. This is quotient rule. How do we do quotient rule? Quotient rule is bottom times the derivative of the top. So bottom is x, derivative of the top is 1 over x, minus the top, natural log of x, times the derivative of the bottom. Well, the derivative of x is just 1, so that's why it's not even there. All over the original denominator squared, which would be x squared. Go to clean this up. X times 1 over x, the x's cancel, you're left with 1. 1 minus natural log of x over x squared. The back of the book is going to be a huge benefit to us today because we're going to have a stopping point that we know we're working towards, okay? You may feel like you're just sort of blindly walking through it, but at least you have an end point in mind. I know that's going to seem a little bit unproductive for you guys, but again, the goal is just that you've been exposed to this, so it's not something that you've never seen before once you get to your college level calc course, okay? I think I'm going to wrap it up with number 5. There's some more examples on the back page, but I don't want to overdo it. I want to give you guys time to work through some of the problems and then let me know what your questions are. So if you look at this, natural log of a square root. Turn that into an exponent, but then use the rule that we talked about yesterday, which is the exponent of a natural log. Excuse me. If you take the exponent, bring it down out front, then it becomes 1/2 natural log x plus 1. This, we don't actually have to do a product rule because it's just 1/2 times it. It's not two separate terms or two separate functions involving a variable. So all we do is the 1/2 comes down. How do you take the natural log of x plus 1? It's 1 over x plus 1 times the derivative of the inside, which the derivative of x plus 1 is just 1. So it becomes 1 over 2 times 1 over x plus 1, so 1 times 1 on top, 2 times x plus 1 on bottom, and that's all it is. Okay, again, having the back of the book as that resource should help us quite a bit. I'm just taking a quick peek at the ones on the back, and basically the examples on the back are just like the ones on the front. You'll have some product rule, you'll have some quotient rule, you'll have some square roots or some roots that you're going to want to turn into and use that exponent rule that we've been talking about the last 2 days. So again, I know there's going to be some questions. I know you guys are going to have some things you need clarification on. That's totally fine. Just push through and remember, it's all about exposure. And number 2, we're done after this section. We're done with the logarithms. We're going to move on to something completely different. But just as, in fact, probably a lot more important for you guys, grand scheme of things, as you get ready to enter your freshman year of college. All right, guys, that'll wrap things up for us. Go ahead, do the assignment. Let me know. Don't feel like you're asking too many questions. If we end up going through the bulk of it, then I might go through the bulk of it and just have you add on a couple other problems from it, okay? So just do what you can. Let me know what your questions are, and I will shoot you a clarification video in the morning. All right, guys, have a great day. Talk to you later.